This is a tank dragster that I designed, and this thing is absolutely wild. These tracks are like a bandsaw, and if you get your hand caught in the sprockets, it's even worse. And my goal is to beat rctestflight's tracked vehicle, which he claims is the fastest in the world at 50 miles an hour. That means we have to go at least 51 miles an hour, but I want to be faster because there's no way we're gonna let Airplane Boy have a chance at coming back against us. And if you can't tell by this gigantic pile of failed parts, this project was actually way harder than I ever thought it would be. This design was inspired by a half-track motorcycle from World War II called Kettenkrat or Crittenkrat, something like that. Either way, it was rumored to have been capable of speeds around 50 miles an hour. So with some modern engineering, we should easily be able to beat that. Maybe, hopefully. And don't get me wrong, regular tanks and tank tracks are certainly cool, but we're trying to break a record, so some innovation is definitely required here. I actually 3D printed the majority of the driveline, and the transmission in the rear is actually the replacement I planned for my rocket car from the last video I did. With the tank tracks, I can test really high loads through the rear drivetrain without actually having to go over like 150 miles an hour, so it is a very good torture test for this transmission itself since I want it for much higher speed applications. The tank tracks are something called attachment chains, and they're used in industrial applications like conveyor belts and stuff. I just felt like the metal chains would be much stronger than a plastic-based design, and custom RC tank tracks that are metal are a fortune. So I think this would be more durable and way more cost-effective than anything else I could have chosen. We stole the entire front end arrangement from our amphibious dragster to make life easier on ourselves because that was already a proven design. I had to carve the chassis and motor mount out of solid aluminum with a jet of hot plasma. Yeah, it's just plasma cutting. I wanted to sound cooler than I really am. And the design itself can handle dual motors in a very narrow package because it is made for speed running after all, so I wanted to reduce aerodynamic loads. The rest of the build was incredibly straightforward except for the chains. None of my chain breakers would work on this thing because of the stupid attachment plates, so I had to go caveman style with a hammer and a punch just to trim it to size. Also, the manufacturer lied, and this is not equivalent to an ANSI 40 chain, so I had to go through several different sprocket designs before I realized this and settled on the correct roller diameter and pitch. It's time for some initial tests. And as expected, the traction on this thing is absolutely terrible. Metal on concrete, who would have thought? It didn't take long for our first catastrophic failure, and this one was a design flaw because I didn't leave nearly enough material around the holes for the bearing retainer, and so it made a really thin section at a high stress concentration that just split under very little load. But with a quick design update and some printing magic, we are back to action in no time. This thing chews up grass like it's nothing. It gets all mashed in these white sprockets, which turns them green like a pair of dad's mowing shoes. And traction was also a major problem. So I designed a few different tread types, way too many tread types. We started with old tread from the tires on my robot chassis because those things were good on all sorts of surfaces. They handled snow, mud, water, and roads like it was nothing. I cut off the usable portion to mount to the chain and quickly realized they would add too much resistance. So they were scrapped for these cheap press-in spikes. And we had our second catastrophic failure almost immediately. This time, we destroyed the gears and the transmission housing. Hopefully this last round of design updates is good enough and our rebuild holds strong throughout the rest of testing. I fixed a stress concentration and bonded on a reinforcement because there's separation occurring at these layer lines that I just can't get rid of with the 3D printed part like this. I also removed all the stupid spikes I put on there because it's actually too much traction. And as any good drag racer knows, you really start to break things when you get a lot of traction. So by limiting the traction, I can limit the total torque through the transmission, and hopefully we survive a little bit longer. Now it's time for us to get back to breaking records. This new design was holding up really well in the last field we broke in almost immediately last time, so I was pretty happy with the strength and setup of this rear transmission. Our runs are strong, but I'm topping out at about 40 miles an hour, which isn't nearly enough. So I decided to run on concrete, but the traction there is terrible, remember? Which led to another round of tread and traction experiments, starting with these stick-on grip pads and rubber grommets that I hope give me just enough grip to run on concrete without destroying my performance on off-road terrain. We brought out our Vendetta this time to remind ourselves how much easier it is to get speed out of a car, and we're off on our first test. That's right, 48 miles an hour this time. That's just 3 miles an hour short of beating the current 50 mile an hour record, which means we're doing a second run, but this time I could tell I was losing traction midway through the pool. And if you look closely at this video, you can see the treads literally flying off as I'm going down the track, which is not good, and it led to, of course, a crash. Somehow all the 3D printed parts held up to the crashing, so we went back out to the grass for one more speed run. And it ran incredibly strong on the grass this time, but on the way back, tragedy struck.
Hopefully just a gear. Oh my God. Look at that gear.
But did we finally break the record? This run was only 41 miles an hour, so no way. Enough's enough, it's time to really shake things up with this gigantic motor. After tearing this thing down for what felt like the 100th time, I realized the rear axle had also been bent, probably from one of the mini flips. I also designed an entirely new motor mount and chain drive so this mega motor could even fit. Even worse, I needed another 6S battery and a gigantic ESC to power this thing. But there's no excuses now, let's go. That's embarrassing. We're topping out in the 30s here. So I pushed the current limit up on the speed controller almost to the max that it can handle, and I was still limited to the low 40s. And this ended up being a total waste of time because I can't put enough current through these motor controllers without blowing them up. So it's time to go with the nuclear option. Dual motors. The transmission was already designed for it after all, and I'm hoping this helps us blow the current record out of the water. I also switched to a lighter chain, which helps me save about a pound of rotating mass, which is huge. Then I went through the painful process of designing custom injection molded traction inserts for this chain. And I'm hoping this helps me really get power down on the concrete. So let's get this over with and finally win once and for all. It turns out custom molded inserts were a bad call because they just threw themselves out of the chain and shredded themselves when I got any appreciable speed, which made traction 10 times worse. I also want to take a second to point out how stupid this thing looks. The electronics and batteries took up so much space that the body wouldn't come close to fitting. So I fashioned these battery and wire protectors out of plastic sheet like some sort of elementary school art experiment. Either way, we have two motors and tons of power. So let's just run this thing on the grass. For the first few runs, the car had more torque than I ever needed, but we were still kind of top speed limited. So I had to swap gearing, and all I had were these lame plastic gears. They didn't even last a full run, which you probably already knew was gonna happen. And by this point, I probably spent well over $100 in just stripped hobby grade gears. To reduce the load on the gears, I'm gonna go back to running on concrete because I'm tired of shredding expensive gears. But this time, we're gonna use heat shrink to improve the traction. I think that'll get good enough grip to keep us from losing control, and it'll stay on a lot better. It feels like it works okay. I also switched back to the original chains because the smaller one just keeps popping off. The reason I originally started with the larger chain is because those larger roller diameters are harder to throw off of the sprocket, and I really wanted that stability. Now it's record-breaking time. Look at that, another failure. We're only hitting mid-40s here. We're going in the wrong direction and life doesn't make sense anymore. So I went back to the original ESC setup and pulled the motor logs from those runs. I noticed that I was pulling just under 200 amps and this ESC can actually handle way more than that. My speed was actually battery limited from those runs, and I have a battery that should get us up to about 250 amps, so I'm going all the way back to square one to see if with the higher power battery, we can get a few more miles an hour. And after a few quick runs on grass, my speeds were 4 to 5 miles an hour than previously, so I'm feeling pretty good. It was around this time that we had our first roller and sprocket failure, which to me is absolutely amazing. These 3D printed parts have held up exceptionally well to crashes and high speeds with no suspension. As a matter of fact, I've gone through 3 aluminum drive shafts before I've ever had to replace any of the 3D printed sprockets. Now we're refreshed and ready to get back at it right after I change the heat shrink to Gorilla Tape for grip. I think it's gonna help me get a little bit more of the grip that I really need, so cross your fingers and let's go.
Think the camera fell off? Oh man, no, it's the GPS.
It turns out the track stiffener vibrated itself loose on this run, and we maxed out at just 48 miles an hour, but we're so close. I also ended up shredding the rear bevel gear. I know we have more speed out of this design, but I want to be absolutely certain that we win on the next go around, so I redesigned this rear transmission one more time. I totally got rid of the rear bevel gear arrangement, which should give me about 5% more efficiency, and hopefully this prevents a few more opportunities for gear slipping and stripping. So late at night, I went back out for another test, and here are the results. Finally, we hit 53 miles an hour on this run, and I know there's more speed to spare. I ran out of room before having to come off throttle, and I came uncomfortably close to this curb from all the way over there. I'm running a throttle delay on this setup, and I was about 20% away from full throttle on that run, so I know I probably have 4 or 5 more miles an hour. I'm just not ready to sign up for slamming this thing into a curb just yet, because I want some more capability testing. And this thing's pretty awesome. It actually does work really well in loose terrain, on solid terrain, if you can get grip, and it looks cool doing it. Now it does have a solid rear axle and no rear differential, so it's a little more prone to flipping in very high grip situations, which you probably saw tons of times on the concrete. But it also makes it way more fun to drive, and I can do these cool little spins and donuts, throw some sparks if I want to. And these tracks have worked remarkably well, and they absolutely ate up loose terrain and grass. I didn't have a single failure of the actual track throughout all of this testing, despite crashes and lots of other things breaking. And I still can't believe how many of these plastic sprockets held up so well through testing. A few of them broke, but most of them did not. So why didn't the dual motor setup get us the speed we were looking for? And the first reason is because I'm running these cheap batteries that suffer from relatively steep voltage drop compared to what I was running on the prior motor setup. I probably lost 15% of my theoretical top speed from that alone. And the motor KV is almost 10% lower than the original setup as well, so that's another 8 or 9 percentage points of top speed drop. I did re-gear for this, but I was limited in the gear arrangements I had because of the spacing width, and I didn't want to redesign the entire chassis and track layout. And that's because long-term this transmission is for a very narrow body streamlined car. It is not for a tank dragster. But if you look carefully to my final transmission design for this tank dragster, you'll see that I do have a spot for dual motors. It just won't package as slim as the other design. But we don't care nearly as much about the aerodynamics of this setup. And honestly, I think either of these rear transmission setups will work really well in a high-speed application. And any of the other designs I have in mind will put far less torque through this transmission. They're really focused on high speeds and not high loads at the lower RPMs. That's it. Thanks for watching, and I will see you soon.